Hi everyone. So this explanation on the HD task grokking. So I'm reproducing from this paper, grokking generalization beyond overfitting on small agronomic datasets, and yeah, I will be first explaining on the basic idea behind it. So I think grouping means that um, the model generalized after overfitting for sometimes or a long time. So if we take a look at this right here, the training accuracy is reach 100 pretty quickly, but it's stagnate there, and the test stagnate as well. But after a while, the test accuracy suddenly spiked up and reach 100. So that's a weird phenomenon that this paper was talking about, and I reproduce it using the same method. Well, I try to using the same method they use. They use a decoder only transformer model and modular operations, many modular operations, but I only use the modular addition. And I have explained it how the modular addition works here, and here's the table I generated based on figure 1 in the paper. I have explained how the transformer works as well at a high level in my a PDF file. I will skip through the training part and I will go straight to the reflection, the conclusion on this HD report. So so I trained the decoder only transformer with 2 layers, 128 width and 4 tension heads. The setup is pretty closely to how the paper have set it up. And so for the first test, I split the training 20% for training and 80% for testing. And I think this is the best demonstration on how grokking works. So if you can look at our accuracy plot, the training reached 100 pretty quickly, but the test it took a while for it. Like the train overfits, the model overfits for quite a while before the test reached 100, and the performance on the accuracy matches the loss. As you can see that it overfit the performance of the training reached 0 pretty quickly, but the test took quite a while, and that's my best demonstration for the other. So the second one, I didn't change the hyperparameter, but I changed the split, and as you can see that because the model has more training data, more exposure to how the operation work, so the accuracy and the loss of train and test is almost parallel. So this is just basic regular training. To me, I think this is not a good demonstration. The third test I did still 50% split, but I changed the learning rate to 0.001, a smaller learning rate than the previous test. And well, it's not really a good demonstration either. We can see that the test still lags behind the train, but the test starts improve alongside the train. So so the model didn't reach overfeeding for a long time before the test reached 100. So I don't think this is a good demonstration either. And I think that grokking does happen based on my first test, but there need to be some condition to be met, and the first one is the split. So the split must be in the lower case. So I found a 20/80 split demonstrates on how the test accuracy can stagnate for a long time but suddenly improve and reach 100. And I think this might be due to how transformer works. So first it's learned by memorizing and then it's generalizing, and as I said, higher speed So we have more training data. So the model has more exposure to training. So to training data. So it so it doesn't really struggle to generalize the data it has been given. And adding a small learning rate can delay the overfitting but slow down the discovery of generalization. So that is not what we wanted. So I think my testing did cover or did confirm that grouping does exist on transformer models, but certain conditions need to be right for it to happen. And yeah, I think that's about it.